I have the test on the brain. Number 10 was B. Number 12 was F. Number 14 was C. They were matching. B, F, C. B, F, C. Number 36, you started getting into equations. Number 36, you started getting into equations. Let me go down so that you can actually see all of it with the graph. Did you guys have to complete the square on this one, or was it as easy as just taking what they had given you? Did they give it to you in a nice, pretty form? Like with it all factored and with the perfect square and all that jazz? Yeah. Okay, good. So you didn't even have to complete the square. Sorry, give me 1 second getting this for Eileen. BC is for Cameron. Okay. Oh, never mind. That was fun. Go team. Any questions on odds? Or evens? Yeah, Dean. 27. Okay. Let me freeze the screen. I see a couple of you guys still grading. Remember, focus in the directrix. You had to find P. And to find P, you had to set, I think it was -1 equal to 4P. And that's how you would have gotten -1/4. Anything else besides number? Oh, stop. Don't be mad. Okay. Any other questions besides 27? Call them out. Okay. For number 27, they did give us an extra characteristic in the directions. If you missed that, it would have been kind of hard. I think they said on number 27, vertex at the origin. Does that look right? Okay, so looking at the directions really quickly, just in case you guys didn't see that, it does say, find the standard form of the equation of the parabola with whatever's down here and the vertex at the origin. So HK is equal to 0, 0. And one more time, I apologize, just making sure. No other questions on evens or odds? Carl, you came in late, and that's okay, but you need to focus. It's pre-cal time. All right. Horizontal axis and passes through the point is the clue for number 27. What does it mean by horizontal axis? The axis of, what's the axis of a parabola called? Axis of symmetry. So if the axis of symmetry is horizontal, which way is my parabola facing? Up, down, or right, left? Good. Right, left would have a horizontal axis of symmetry. Do we understand that? Up, down would have a vertical. Okay, so we know right now, horizontal axis of symmetry, we're dealing with, did you guys follow kind of what I was doing yesterday in class? Where you try to figure out what general form you're using first. You know what I mean? From the horizontal axis, as soon as I figure out it's either right or left, it's not a hyperbola, but it's either right or left, then I know, oh, I'm doing this one. I'm doing this one where the y is being squared. How many of you guys did something like that, like you started there? Huh, okay. So you guys maybe just saw it and then just went straight to plugging in. What can I plug in right away from the directions? 0, 0. So I can go ahead and say, all right, I know it's going to be. What's the one thing I'm missing? My P. I need to go look at that clue up above. Huh. Is that the focus? They don't say it is. It's just a point. Well, if it's a point, isn't it just an X and a Y, like a general one? Does it tell me anything about P directly? Nothing. It's not the directrix, it's not the focus, I'm totally stuck. But even though I can't plug in for P, what can I plug in for? So if I go plugging in my Y, 5 minus 0 squared will be 25. 4 times P, I don't know what that is, but it's going to be whatever is resulting once I plug in the rest of what I know. So therefore, that coefficient, that distance to the focus and backwards to the directrix is going to equal negative 825 over negative 8 is negative 25/8. And so I think just to finish off, we can just go ahead and write what we know. Y minus 0 squared equals negative 25/8 times 4. Wouldn't that reduce to be negative 25 halves? Times x minus 0. And of course, we could make that a little bit prettier if you guys want. Does that match up with what you guys found? Cool. Yeah, that one was weird. They didn't directly tell us anything about the focus or directrix, and so we were stuck until or unless you realized, oh, that point has to work. All right, I'll plug him in and figure out who P is indirectly, basically. All right, with that, those are all the questions that you guys said you had. So section 10.3, the plural of ellipse. Ellipses, ellipses, but ellipses is technically something different, so ellipsis is even different. Anyway, we'll just say ellipses. How to graph an ellipse. If you guys notice, there's a yellow box coming. I'm going to zoom in on that in just a second, but I'm giving you guys a zoomed out look so that you guys can get set up. Let me go and zoom in. You guys should at least have the idea of the first down, right? I think I can make it, let's see. There we go. Should be able to see that a lot better. Sorry, the words are kind of distorted. On the second one, I just wanted to be able to show it to you. What if it was vertically oriented? That's the bottom one, instead of horizontally oriented. of us are here. One tardy excused. Okay. All right, kiddos, if you notice in the backboard really quickly, once you do finish, we're not going to finish this entire section today. Doesn't mean that you can't start homework, and some of you proactive ones, independent ones, you could probably finish the whole homework over break. Have a nicer Monday night when you get back. But for those of you that are like, I'll start it, but I won't finish it, I'm saying that because homework is to start it, obviously, whether or not you choose to take me up on that advice. But what else could you be working on if you don't want to, if you don't want to necessarily finish the section since we're going to continue it on Monday? Test corrections would be a great idea. On the backboard, I have due Tuesday. That way, if you do have any questions, you can come in after school Monday. Tuesday by the end of the day. So you do have a little bit of time when you get back in case you got stuck on a couple. But my advice would be try to correct as much as you can over break. Yeah. Okay. So with this, do a quick illustration. Except I lost all my scissors in the Havana Nights fundraiser, which was very sad. Hold on. I can think outside the box. I got this. I have two good pairs, too. All right. If anybody randomly finds scissors, I would love some. I mean like permanently, sorry. If you find some around campus. If you're working for a teacher in Mr. Brache's office and happen to see extra scissors, I would love to have some. Probably for all her projects, though. You guys do a lot of Spanish projects, right? Yeah. Okay. Shh. I thought I was doing well with two. I didn't keep a close watch on them. Here we go. Do you guys see how I'm trying? They're somewhat even. I'm trying to demonstrate the two. Let me go back to the page before. I'm trying to demonstrate the two foci. The two foci for an ellipse. An ellipse does have a center, and I'm going to be very approximate on this. Looks like right about there. Okay, an ellipse does have a center, but an ellipse also has two foci. I'm going to put this one on top of there. This one on top of there. Approximately, not sure this is perfect, but that's all right. It'll get the idea across. This one should probably go down just a little bit. Okay. The idea of an ellipse and how it's formed. The idea of a circle is pretty easy because it's one center with one set radii. Think of a compass. Set it at one length. Hopefully, if it's not one of those old ones that like randomly falls down, then your circle looks awful. But the compasses, you guys remember, it's the little tool and then you spin it and it makes a circle, right? Thanks. Anyway, my couple that responded, yes. Compass. One set length, go all the way around the center, right? Okay, and don't hurt anybody with the pokey thing. Okay, ellipse. You guys never had the dangerous ones, the pokey thing in the metal and then... All right. An ellipse, a little bit different because it's not one set length, one set radius all the way around. Instead, an ellipse, if you look at the picture, has two different radii, and actually not even two different radii, everything between those. It has a minor radius is what I'll call it. A minor radius and a minor diameter. That's the smallest distance across the shape. And it has a major radius or a major diameter. That's the longest distance across the shape. And then it technically has everything in between. As it goes from the smaller to the larger, it's going to hit every radius in between. But how is this shape formed? If you have a string connected at the focus, Now it's going to be a little off because now it's the other direction. But we'll pretend it's going to be close. What's formed, roughly? What's formed when I finish? The ellipse. Now, technically the ellipse would go a little bit more over here. The ellipse would go a little bit more over here if I was to connect. And then that's this one, it should technically be a little bit lower because the way it was oriented on here, it was a little more distance this way, a little bit less distance that way. But this would be my ellipse. And that's what this visualization is trying to show you on the first page. The construction of an ellipse is such that D1 plus D2 is constant. Wherever the circle is, wherever the point is on the circle, it's kind of like a string where D1 plus D2 is how much or how long, the length of the string that you're using. And then with the slack, you're actually drawing the ellipse. So if the foci are super, super close together, you guys saw where these foci were. They were actually quite far from the center. If the foci were very, very close together instead, let's go here. What do you think is going to happen to my ellipse? Is it going to be more circular or more elliptical? More circular or more elliptical? We're thinking elliptical. Sure looks a lot more circular to me, right? And what's the reason why? Ooh, pretend. What's the reason why? What if the two foci were at the same point? What would you have? A perfect circle. So the farther the two foci are from each other, the more elliptical the shape that you have. And the closer the two foci are, the more circular the shape. There is a measurement of that. The visualization, is what's on the board. You can be like, string, magnets, draw with expo. I don't know. But anyway, that's the visualization. There is a measure for how circular an ellipse is. It has to do with something called eccentricity. Ugh, that got nasty. It's because I stopped tracing at the end. But eccentricity, we'll write about it, I think, before we finish the section. It might be on Monday or it might be today. We shall see. P.S. Happy Thursday. Break is almost here. Hang in there, yeah? Okay. Why is this page important? Lots of formulas. Wait a minute. What are these called? Vertices of a circle? It's not really a circle. It's an ellipse, number one. And number two, technically, do you guys see how the actual label of vertex is only on the major axis? Now, are there points on all of the ends for us to connect? Yes. But the vertices are technically only on the major axis. That's not the focus. The vertex is literally on the outer boundaries. And as I was saying before, we can talk about this measurement as the minor axis is the entire thing. This measurement could be the minor radius. And here's the nice thing. The minor radius is going to be, let's see, the y-axis is the minor, so I'm looking at the y component or the y term. The minor radius will be the length of b. In this example, the major radius, what do you think the major radius is going to be? Yep. And guess what the center is going to be? HK. The center is going to be HK. So far I've talked about, well, let me move my HK closer to the center. There we go. So the center is HK, the minor radius is B, the major radius is A. In this example, A is greater than B. If you look down here in this example, A is also greater than B because now this time the major, this is going to be underneath the vertical term because the major radius is vertical. This will be A. The minor, this will be B. Common notation, A is always greater than B for ellipses. Just common notation. But the nice, oops, it's supposed to be a B. Shoop. Now it just looks weird. Okay, A is going to be greater than B. A is just the name for the major wherever he is. So if the major is underneath the horizontal, it's going to be a horizontally oriented ellipse. And if the A is underneath the vertical component, it's going to be a vertically oriented ellipse. But the nice thing is, if you just think about this guy's square root, whoever this is, will always be the distance vertically to the edge, whether up or down. And this distance, the square root of, will always be the horizontal. Sometimes it'll be small, sometimes it'll be long. Doesn't matter though. Always horizontal when you square root, always vertical when you square root, whatever you do. Let's see, is there anything else we should talk about? The vertex. The vertex on this one is going to be, let's see, the y's stay the same, and the h's need to add and subtract a. The vertices over here, what stays the same now for these vertices? The h stays the same, the x stays the same, and the y is going to add or subtract a. Okay, I guess that's it. Let's see what we can do with it. Sound good? Let's see what we can do with it. Pause real quick. Why is this not a parabola? I see a squared. Ah, both the x and y's are squared. Not so much for the beneath. We're going to have to actually remember that this is supposed to be somebody squared. But we're going to see the x's being squared and the y's being squared. And what sign do you see in between? Positive. There can be minuses, like in the x terms or in the y terms, there can be minuses in there, but in the squareds, they both have to be positive. In the squareds, they both have to be positive. All right. Oh, hey, that was the visualization. Go team. Lo siento. I forgot I moved it so that you guys could take notes to be ready for class. All right. Ooh, foci, sorry. I forgot. I separated the foci. We didn't talk about them yet. I mean, we did in the picture. We didn't here. The foci, if you noticed, wherever the foci are, is going to be, well, you kind of can tell from here. The foci I put horizontally apart from each other. It ended up being horizontally oriented. If I made the foci vertically apart from each other, then it'd be vertically oriented. So for this one, the foci are going to be kind of far from the center on the major axis, which in this one is horizontal. This one also kind of far from the center because this is pretty elliptical. And on the major axis, which is vertical. But how do we find the foci? You know the center is HK. That's already determined. You know the center is HK. That's already determined. We have to add something, but there's no P. That's only for parabolas. Ooh, P for parabolas. Go team. Maybe that'll help you remember. If you look up here, points on the major axis, C units away from. Uh-oh. We got to know who C is. Looks a lot like Pythagorean, but it's not. It's not a squared plus b squared. It's a squared minus b squared. But once we find C, so if you want to think of it that way, C is equal to, in a sense, plus or minus square root of a squared minus b squared. You can think plus or minus in the sense that we're going to be adding it and subtracting it because there are two, bless you, foci. So focus number, well, let's just say for both the focus. The points are going to be for this one. Keep the K, right? And add and subtract C from H. The K stays the same. For both of my foci, for one of them, I'm going to add the C. For the one to the right, I'm going to subtract the C for the one to the left. So you guys help me out. What will be my formula for these two guys? Who stays the same? H. Good. H stays the same. And how's K changing? Got it. See how the patterns are similar for parabolas and ellipses? In the sense of, okay, we're going to have to have things be factored. So maybe some completing the square again a little bit. But we're going to have the x term be factored, complete the square, the y term be factored, complete the square, struggle. we're going to have to get some things being divided. That might be kind of weird. But as far as the focus is concerned, we're still kind of adding and subtracting based on the orientation. Just this time with ellipses, we kind of have stuff going on both directions. With parabolas, it was just kind of on the axis of symmetry. So in some ways similar, in some ways different. But instead of a P again, now we're dealing with a C. Now let's play. Sorry, I have a couple people still writing. You guys have all your formulas, yeah? Have you started and highlighted, which you're pretty sure will be important? Okay, let me go ahead and dual page real quick, just so some of you guys can be looking at the example. This one, a picture has been given to you. The directions say, use the picture to write an equation. Use a picture to write an equation. Everything has been given to you except for the foci. But if you notice in the equation, there is no C. Unlike parabolas, the P was in the equation. For ellipses, C is not actually in the equation, so we don't actually need it. We don't need the foci. How would you plug in? You guys keep doing what you're doing. I'm just doing what I started with yesterday, which was, well, let's start with something to plug in. Not that it's a huge deal, but it does match what our formulas say. Why did I put the A under the X one and not the Y one? Good, it's longer horizontally, right? Does that make sense? Okay. What'd you plug in for HK? Good. Who's A? Horizontal distance from the center to the outer edge. It's the major radius. Not all the way across, not the diameter, just the radius. So what is that distance? Yeah. So 2 squared, which will end up being a 4. What's the minor radius going to be, or B? 3 over 2 or 1 over half? Sorry, 1/2. 1 1/2. 3 over 2. Would they make this look a little prettier? Probably. You could do x squared over 4 plus, can we do 4y squared over 9? And know what I'm talking about? Because it would have been over 9/4. Dividing by 9/4 is multiplying by the reciprocal, 4/9. And just in case they did want it in like standard conic section form, this would be standard like ellipse form. But remember standard conic section form, the ax squared plus bx plus cy squared plus dx plus ey plus f is 0? 0. How could you get equal to 0? Subtract 1? I guess so. But another way is that you could have multiplied everything by a 36. If you multiply everything by a 36, you would have 9x squared plus 1 and 4, 4 and 4 is 16. 16y squared equals 36, which I could have moved to this side. That's also another form of the ellipse. Because I would have gotten 1 and 9 x squared plus 1 and 4, 4 and 4, 16y squared equals 36. Subtract it. That would have been the conic section standard form. And if you notice, the x is squared, the y is squared. There's an addition in between. But the 9 and 16 don't match. Now hold on, wait a minute. What if the 9 and 16 did match? I think we didn't fill in a blank back here somewhere, right? What's this green standard form of a circle trying to have us review? Did anybody fill it in because they just remembered what it was? So check it. If we were to think about the standard form of an ellipse that we've been seeing, the x minus h squared all over a squared or b squared plus y minus k squared all over a squared or b squared equals 1. Wait, 1? We could make this equal 1, but we'd have to divide everybody by r squared. A circle can show up looking like an ellipse, but what's going to be funny is that these two will be exactly the... Oh, that makes sense. Major, minor, exactly the same. What am I going to have? A circle. I'm going to have a circle. So, a circle is a special ellipse. Every circle is an ellipse. Not every ellipse is a circle. How about this guy? Ooh, the clues have changed. Fine, the standard form of the equation of the ellipse having. Get down your clues. Be pondering, that's good, just no answers yet. Be pondering, that's good, just no answers yet. P.S. Feel free to collaborate for a minute or two with your groups. Let's see how far you can get. How many groups did they have it? Oh, not yet. Okay, hold on. Talk it out. Talk it out. I heard a couple people talking. It's all right. Think it out. This one you can find C, and maybe from C, and from the clue, the extra clue up above. Prove it. Are we just guessing something? No. I'm not guessing anything. I walked in on them finishing it this morning.
We know it's. That's
Whole.
Would it be the or just because is like one.
With a major axis, the major axis is the whole. Radius. Yeah.
Yeah, I knew it was.
So A equals 3. What does C equal? Doesn't C just equal 2? Distance from the center to the focus. Major axis is the whole thing. Major radius would just be 3. C would be 2. Hey, isn't there a C squared equals A squared minus B squared formula? So couldn't I say that 4 is equal to 9? I don't know why I was about to write 6. Minus B squared. So wouldn't B equal root 5? Ooh. Go team. So then can't I start with my formula and say, well, x minus plus y minus equals 1. What's my center? 2, 1, yeah? Throw in the a squared. Throw in the b squared. Root 5 times root 5 is root 25, which is... And if you wanted to make it look like a nice, pretty conic section, multiply both sides by 45. Dun, 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 dun. Oh, man. I feel like we're getting through this really well. Does that mean that we're pretty much done? Oh. Oh. We're so close to done. There's this special name called eccentricity. If you want to throw down the formula, we basically could be done. We'll probably still grade on Tuesday, but I'm not really sure we would need to. I skipped an example that needed completing the square, but I've talked about that guy a lot. So I'm going to go ahead and freeze the screen so that you guys can get down your formula for eccentricity. Do you know how to find C, or do you know what C stands for? Yes. Distance to focus from center. Do you know what A stands for? Yes. Major radius. So all we're missing, basically, is an example where I say something like, hey, you'd have to get the x terms and the y terms, and then complete the square on both. Okay, we'll do that example on Monday. But I think you guys basically got it. Ready, set, go. Bye, guys. Happy Thursday. Happy break, almost.